Hello! In this video, we're gonna focus on one of the most important integral rules called integral by parts. Generally, when you find your function, as it is the multiplication of f of x and g of x, and you are asked to find the integral of f of x to the g of x, what you should finally do is to use integral by part rules. So maybe this is just you don't know how to do it by looking at it, because I don't. We have this product here. What should we do? First of all, let me tell you how and when you are allowed to use this method. Whenever you find a function multiplied as a polynomial function to a trigonometric, or exponential function, or logarithmic, or even the multiplication of polynomial function and inverse trigonometric function, or another one, the multiplication of exponential function and the trigonometric function. Here it is, you can use the integral by part rules. So let's have a look on what the formula is. Integral by parts has got a formula that says that the integral of u dv would be equal to u dot v minus the integral of v du. As you see, the left-hand side of the equation is the integral asking the question. It must be solved, alright, and the right-hand side is the answer of the problem asked. Here you see there's a new product integral, the integral of v du. Why should we do that? Because hopefully the new integral is easier to do and needs no substitution or anything else, so it can be easily solved. Before I talk about this formula completely, let's have a quick look on its formula. Alright, as you know, derivative got some properties like being linearity, so the differential would be the same. Also, derivative of the summation of two functions would be the derivative of the first function plus the derivative of the second function. Let me tell it again. This rule also applies to the differential. Now the derivative of the multiplication of two functions. Here you have to evaluate the derivative by the derivative formula for multiplication. That would be the derivative of the first function multiplied to the second function plus the derivative of the second function multiplied to the first function. Also, we have the same formula for differential. On the other hand, the integral does have the linearity property and effects on the summation, but there is no formula set for the integral of the product. So, this is why we set the formula using the differential written here. And you see, here I take the integral of this differential function. What would be the result? I will finally evaluate the integral of the multiplication of two functions. So the integral of du dot v is equal to the integral of v du plus the integral of u dv. And the integral of du dot v is equal to the u dot v by changing the position of the integral of v du to the left-hand side of the equation. So this would be the formula. And here you see, this is the formula we've just called the integral by parts formula, or better to say the integral of multiplication of two functions. I'm going to show you how to evaluate the integrals using this formula. So look at the example below. Here we have the integral of x cosine x dx. Alright, I've got a question. Can I integrate it by parts? Definitely yes. Why? Because the given functions got the type of being polynomial and trigonometric, as we said before. The left-hand side integral, the integral of x cosine dx is equal to u dv. I just need to take one part as it is u and the other part consisting of dx as it is dv. Here we have x as it is equal to u, and I got cosine x dx as it is dv. Look at the formula. You have to also find v. Here we have both u and v, also du and dv. But all we got was u and dv. So we have to find du and v. Don't worry, I'll show you how to find du and v from this formula. Du is differentiating u and integrating dv to find v. Here you see the integral of dv is v, and the integral of cosine x dx is equal to sinus x. Alright, we got u, du, dv, and finally v. In the next part, I only have to put them in a formula. So I can evaluate the right-hand side integral. The integral of u dv is equal to the integral of x cosine x dx, and here we have u dot v, which we got u as x and v as sinus x minus the integral of v du. Here we have v and du. So we have the integral of sinus x dx. As you know, the integral of sinus x dx would be negative cosine x into negative. That would be cosine x. So the integral of x cosine x dx is equal to x sinus x plus cosine x plus c. You see, I told you that the right-hand side integral became simpler than what was on the left-hand side. Well, I have something new for you. The integral of x e to x dx. All you have to do is finding u and dv and plugging it into the formula. So we differentiate u to find du, and we integrate dv to evaluate v. That the integral of dv would be v, and the integral of e to x dx would be e to x. Now we got what we needed, u, du, dv, and also v. By plugging them to the formula, we'll have the whole answer. We have a trick. So the integral of u dv is our integral, the integral of x e to x dx. Due to u dot v, which u is x and v is e to x, it will be equal to x e to x minus the integral of v du, which v is e to x and du is dx. All to do is evaluating the integral of e to x dx. You see how easy it is to evaluate this integral? So the integral of e to x dx is e to x. Finally, our integral would be equal to x e to x minus e to x plus c. You may ask yourself, why would I choose x as u? Or you may ask, wasn't it possible to take e to x as u? Or wasn't it possible to take x dx as it is dv? Now we're going to consider on this problem to see what the result would be. Alright, I'll take u as it is e to x and dv would be the rest, x dx. What's next? We're going to evaluate du and v. Du would be e to x dx and v would be integral of x dx, and it is equal to x squared and half. Now we're going to plug u, du, dv, and v in the formula. The integral of u dv is equal to x e to x dx, and here we got x squared and half e to x minus the integral of x squared and half e to x. You may panic, because the produced integral is much more confusing than our integral, and it may not be integrable. So, as we mentioned before, by choosing x in the place of u, this became integrable. Friends, if you pick u and dv wrongly for several times, don't panic, it's okay, and part of getting good at something is bumping up against when it doesn't work. Anyway, I have just a thing for you. A trick helps you pick the right u. Alright, we faced the integral by parts method was the integral of two multiplied functions, the integral of f of x multiplied to g of x. Now we face two cases. The first case will be the time that we know the integral of both functions. Next, we will evaluate the integral of the function that is simpler, and that will be picked as u. For instance, we'll have a look on this integral. Here we have f of x as it is x, and e to x is g of x. In this case, I know the integral of both functions. Now tell me, which one is more soluble? I picked the simpler one, and it would be u. And the x function is simpler to solve. So we consider x as it is u, and we've just talked about what the whole answer would be. And there's a second case, which is suppose that you do not know the integral of one of these functions. Surprisingly, that function that you do not know its integral is u, because if you pick that unknown integral function as dv, you have to integrate it due to the formula to find what v is. But we don't know its integral, so integral by parts won't work. That's why we pick u as the function that we do not know what its integral is. Let's put it all in test. Multiplication of x to ln x. Obviously, I know the integral of x dx. What about the integral of ln x dx? I don't know, so I pick it as u according to the second case. Here we have u equal to ln x, and the rest of it would be dv. Then we evaluate du, it would be dx over x. Well, I find v by evaluating the integral of x dx. It is equal to x squared and half. Alright, I got u, du, dv, and v. By plugging them into formula, we'll have the integral of u dv, as it is the integral of x ln x dx equal to u dot v, as we have v equal to x squared and half, and we have u equal to ln x. So u dot v would be x squared and half ln x, then minus the integral of v du, which v is x squared and half and du is dx over x. By simplifying this integral, we'll have x squared and half. To summarize, the integral of x ln x dx would be x squared and half ln x minus x squared over 4 plus c. Remember, the more you practice, the smarter you become. Thank you for following us. I hope you completely understand integral by parts.